Okay, chapter 2, section 3. We are talking about conditional statements. Okay, I'm sure your parents have used conditional statements on you before. For instance, if you clean your room, then you can go to the movies. If you have good grades, then you can get a new phone. All right, it's any statement that is in the form of if something, then something. All right, the phrase that follows if is called the hypothesis. So in this statement here on the right, an angle is a right angle. That is our hypothesis. And that's the thing that has to happen first. All right. The conclusion comes at the end. It follows then. So just the phrase, its measure is 90 degrees. That's our conclusion. All right. I'm going to be doing a lot of typing so that my computer cooperates with me. Feel free to pause if you need to write down, but I will also try to go at a decent pace so that you don't have to try to play catch up. All right. So down here, we are just practicing. We are given a conditional statement, and we are just practicing identifying hypothesis and conclusion. All right. Hypothesis of this first statement, again, is just the phrase that follows if. So if someone has an Indiana driver's license, that is our hypothesis. That's the thing that has to happen first. Our conclusion comes at the end of the sentence after the word then. So the phrase they are 16 or older is our conclusion of our first example. Okay. Second example here, the statement is if you live in Indiana, then you live in the Midwest. So the phrase that follows if is you live in Indiana. Our conclusion follows then, which is you live in the Midwest. All right. Example 3. If the forecast, I'm going to change this, shows rain. Forecast is rain. I do words good. But again, the hypothesis is just the phrase that follows if. It does not include if. So the forecast shows rain. Our conclusion comes after then. So forecast shows rain. I'm going to take an umbrella with me. Okay. Now the next set of examples, we're actually going to practice writing conditional statements. Okay. The important thing to remember, start with the word if. Right? All conditional statements will start with the word if. And then the hypothesis is the thing that has to happen first. All right. So if an animal is a mammal, then it is warm-blooded. Right. Then has to be in the middle of that conditional statement. Okay. Sentence 2 is all apes love bananas. So let's say if an animal is an ape, then it loves bananas. All right. Those first two examples, I think, are good examples because the conditional statements that we're writing don't have all of the same words, but they still, the conditional statement still has the same meaning as the original statement, which is very, very important. All right. Example 3, dogs wag their tails when they are happy. All right. When we're writing these conditional statements, when is a key word to look for. Okay, dogs don't wag their tails and then they become happy. Dogs are happy and they show that by wagging their tail. Okay, so when the phrase when in that sentence in number 3 tells me that if dogs are happy, the dogs being happy has to come first. Then they wag their tails. All right. Example 4. Let's go with if two angles are supplementary, then the sum of their measures is 180 degrees. Okay, and we know that when we state two angles are supplementary, we know that their measures add up to 180 degrees. We learned that in chapter 1. Okay, something else we learned in chapter 1, the phrase collinear. Collinear means that points lie on the same line. So if points lie on the same line, then they are collinear. All right. So again, conditional statements have to start with if. Hypothesis follows if. And we end the sentence with then, and then whatever the conclusion is. Okay. Now, a counterexample. This is a vocab word. If the conditional statement is always true, we will not have a counterexample. Okay, but some statements that are presented might not always be true. And in those cases where you can think of one time or one case where the conditional statement is false, that is your counterexample. Okay, so example 1 here, if you divide an integer by another integer, the result is also an integer. All right, so whole number divided by whole number equals whole number. It's essentially what that is saying. Okay, now that is false. All right. Like 8 divided by 4 gives us is an integer divided by an integer equals an integer. But let's take, for instance, 2 divided by 3. 2 is an integer, 3 is an integer, but dividing them is not an integer. It gets us a fraction. Okay. Example 2, if next month is August, then this month is July. Well, ask yourself, does August always come after July? Yeah, that's true. So since this statement is always true, we do not have a counterexample. Okay. Example number 3, if angle A is acute, then the measure of angle A is 35 degrees. I mean, that might be true. 35 degrees is an acute angle, but so is 47 degrees. Okay. You give one instance. You can give any other degree measure that would still make angle A acute, and that's going to be a counterexample for that conditional statement. Okay. Now, we've got other statements that we can write. Okay, and these are called conditional variations. All right. The first one we're going to talk about is the converse. Okay. Just as a little refresher, this was the same sentence, same statement that we had at the beginning of the notes. Okay. An angle is a right angle, is our hypothesis. Its measure is 90 degrees, is our conclusion. All right. And being able to identify hypothesis and conclusion is very important for these variations, okay? So if and then do not change places at all when we're writing these variations. It's only the hypothesis and conclusion that are changed, all right? And to write the converse, we switch them. All right, so our converse would read, if its measure is 90 degrees, then an angle is a right angle. All right. Now, if you want to say if an angle's measure is 90 degrees, then it is a right angle, and kind of change the subject. Oh, what parts of speech are those? Don't know. This is math class. But if you want to make it sound better to you so that it makes more sense, please feel free to do so, okay? Just make sure that you don't change the meaning of the sentence when you do that, okay? So, we're going to write a conditional statement based on the sentence, lions are cats that can roar. So, if a cat is a lion, then it can roar. Sure. Makes sense. House cats don't necessarily roar. All right. Now our converse, if and then are staying in the same place, but we are switching those phrases that follow. So if a cat can roar, then it is a lion. Okay. That's all. All right. Example 2. Two angles that have the same measure are congruent. All right. There are a couple different ways you can write this original conditional statement. Up to you. Okay. I'm going to say if two angles have the same measure, then they are congruent. All right. Now the converse of that, we still start with if, but now the congruent part is what's going to come first. If two angles are congruent, then they have the same measure. All right. Now, we haven't really talked about true or false in terms of writing these equations, these statements. All right. But now we're going to start talking about it. So, if the original conditional statement that we're given and its converse are both true, okay, we'll make that purple. You can write what we call the biconditional statement. Okay, biconditional, bi meaning two. So two variations of a conditional statement, or two conditional statements. All right, and to do the biconditional, we stick the phrase if and only if between the hypothesis and conclusion.
Mama, I need to potty.
Okay, bud, can you please tell Daddy? Or you can just go by yourself. That's fine. All right. So this first example here. If two lines intersect to form a right angle, then they are perpendicular. That is true. All right. We know that's true from chapter 1. Okay. To write the converse, we switch the phrases that follow if and then. So if two lines are perpendicular, then they intersect to form a right angle. Okay. That is also true. So since the original statement that we were given and its converse are true, we can write the biconditional. All right, we take the hypothesis. In this case, it is two lines are perpendicular. We take the conclusion. They intersect to form a right angle. That comes at the end. And our phrase, if and only if, comes between them. Okay. So the biconditional statement reads, two lines are perpendicular if and only if they intersect to form a right angle, which makes sense. Okay, example 2. If you live in San Diego, then you live in California. True statement. All right. The converse, if you live in California, then you live in San Diego. That's true sometimes, but I have a softball teammate from college that lives in Rancho Cucamonga, California. She does not live in San Diego, but she still lives in California. I have another teammate from Fresno. Again, Fresno, she lives in California, but that's not in San Diego. Okay, so our converse is false. We can provide a counterexample for the converse. Okay, or converse is not true. All right, example 3. If two angles are complementary, then the sum of their measures is 90. That is a true statement. All right, so now we're going to write the converse. If the sum of their measures is 90 degrees, then two angles are complementary. Boom. We know that's true from chapter 1. So we can write our biconditional. Okay. Again, we take the hypothesis. Two angles are complementary. That phrase, if and only if, falls between that and the conclusion. The sum of their measures is 90. Okay. Now, last two things we're going to talk about are these other related conditionals. You will not be assessed over these two statements, but they're important to know when you move forward, especially for standardized tests such as the SAT. Okay. The inverse. The hypothesis and conclusion stay in the same place. All right. So we're still going to use that statement that we did up here. If an angle is a right angle, let me copy this. Then its measure is 90 degrees. Okay. So again, converse. We just switched hypothesis and conclusion. All right, I'm going to move this. We'll put this right here. Oh. All right, so we are not moving the hypothesis and conclusion. The angle being a right angle is still coming first. The measure is 90 is still coming last. But we do what we call negate. And negate kind of looks like the word negative. So that means we're going to make it mean the opposite. Okay. So the opposite of being a right angle is not being a right angle. And the opposite of its measure is 90 degrees would be its measure is not 90 degrees. So that is our inverse. If an angle is not a right angle, then its measure is not 90 degrees. Okay. And the contrapositive, taking that same statement. All right. And now we get to do both things. We switch the hypothesis and the conclusion. So we'll go ahead and just do. But we also need to make both parts mean the opposite. Okay, so the opposite of measure is 90 degrees. This measure is not 90 degrees. And the opposite of an angle being a right angle, an angle is not a right angle. Okay, so that's our contrapositive. Again, we will not be assessed over those two, but they will be helpful to know.